Welcome to qnawire.
To express the confidence interval 43.4% to 55.2% in the form of p hat plus or minus the margin of error, we need to determine the sample proportion p hat and the margin of error me. So given the confidence interval, we can calculate p hat by taking the average of the lower and upper bounds. So p hat would be equal to 43.4% plus 55.2% divided by 2. And I'm going to convert that to a decimal. So 0.434 plus 0.552 divided by 2 is 0.493. To calculate the margin of error, we need to consider the sample size and the standard error. So the standard error is equal to the square root of p hat times 1 minus p hat over n. And so that's going to be the square root of 0.493 times 1 minus 0.493 over n. Since we don't have a sample size n, we can't determine the margin of error directly from the confidence interval. So the confidence interval represents the range of possible values for the population proportion, but it does not provide information about the sample size of the standard error. So without more information about the sample size or standard error, we can't express the confidence interval in the form of p hat plus or minus the margin of error. But since the confidence, we can actually use the formula margin of error equals the z-score times the square root of p hat times 1 minus p hat over n. We know that we still need an n. So I might be missing some information, but you can use the z-score 1.96. with the p hat .493 times 1 minus 0.493 over n. And if we're missing some information and you know what n is, then you're able to complete this formula and go back to plugging that in here. Because we have p hat, it's going to be 0.493 plus or minus. We need n to find the margin of error though. A political candidate, for the second part of your question, I'm going to determine the size needed to achieve a specific margin of error at a given confidence level, we'll use n equals z squared times p times 1 minus p. All of this over e squared, where n is the sample size, z is the z-score, p is the estimated proportion, and e is the margin of error. In this case, the candidate wants a 3% margin of error at a 95% confidence level, so the z-score is 1.96 at that level. Using a conservative estimate of p equals 0.5 and converting the margin of error to proportion, that would be 0.03, we can plug in the values to calculate the sample size. N would be equal to 1.96 squared times 0.5 times 1 minus 0.5 all over 0.03 squared. Let me calculate this. 1067.1, and it says give your answer in whole people. So I would say 1067 people.